Thanks. Hi, everyone. Thanks, Merv, for letting me get up and speak to you all. Yeah, I'm here to talk to you a little bit about network security and a little bit about breaking into computers over the internet. But more importantly, I'm not here to show you how to hack into things. It's, well, a little bit. The goal is more to show you how easy it is for other people to do that, and how to better protect the software that you write and the things that you install and set up. Before I start, a show of hands. Has anyone ever reported a security vulnerability to some software or site that they use? Couple, okay, good. Maybe you should definitely be up here instead of me, because I have not. And has anyone who has had to update a library or some software that they use because of a reported security vulnerability? Great, okay, good for you. For those that have, I hope that this kind of reiterates why that's so important. And for those that haven't, I hope that it scares you into making sure that you always do. Can everyone hear me at the back? Okay, am I speaking loud enough? Okay, if I'm not, then tell me to shout. Okay. Before I start, a little bit about who I am. Yeah, my name is David. I studied computer science at York University, and I graduated back in 2010. And since then, I've done a bunch of dev jobs here and there, and currently I am the head of engineering at a company called Pixie Labs. Thanks. We're a software development agency based here in Shoreditch, just up the road. And we solve problems for businesses using software and technology. Everything from big data platforms for analyzing government spending to bespoke e-commerce solutions. We once made a 40-year-old typewriter type by itself when you tweeted at it, which was quite fun. All of those things have benefited from having a little bit of understanding about this sort of side of network security in terms of, how people might try and break into your stuff. So back in August, actually, Stephen Lewis, is Stephen Lewis someone who's here? Hi. He did a talk on network protocols. Was anyone here for the talk on network protocols? Cool, okay. So for those that are here, I'm going to go through a little bit of a refresher of a little bit of that. And for the rest, don't worry. I'm going to cover just a little bit of background of how computers communicate with each other over the internet, which is kind of necessary to understand some of the tools that I'm going to demo and the things that we're going to do. And although the talk title is general, like breaking into computers over the internet, I'm going to cover really just one specific attack vector for this talk. And that is, I mean, there's a lot of them. There's a lot of different attack vectors, and I'll go through some of them at the end. But we're going to look at scanning a remote computer somewhere on the internet for possible avenues of attack through the services that are running on that computer. So for example, you might have a computer on the internet that's set up to serve a website, or maybe it's set up to receive emails, or maybe it's set up to share its remote desktop, something like that. And then once we know the services that are running on that remote computer, we're going to look at exploiting known vulnerabilities in those services using common tools that are available to anyone. Specifically, I'm going to demo using Metasploit. Has anyone heard of or used, not maliciously, used Metasploit before? Okay, cool. One, two, a couple. Great. And then I'm going to look at protecting against this specific attack vector. And then also, as I say, talk about a few others that I'm ignoring. Okay. Before I do that, a disclaimer. The tools that I'm going to talk about are completely legal to own. It's totally fine. Because they have a bunch of legitimate uses. Maybe you're doing what we're doing, checking stuff that we've written ourselves to make sure that it's secure. Or maybe you're a penetration tester and you've been hired by some company to check their systems to see if they're vulnerable to common attacks. So the key is that using these tools is only legal if you have permission of the target. At best, it's a gray area in the case of some of the tools, and at worst, you definitely immediately fall under the Computer Misuse Act. And you can actually really quickly get in trouble. This is an email that I got from AWS when I used one of the tools that I'm going to demo today from a server in Amazon Web Services to another server in Amazon Web Services. I did have permission, but literally as I was doing it, they sent an email being like, "What are you doing?" So definitely don't target systems that you don't have permission to target with these tools. The other thing is that I'm not a penetration tester. I'm not a security researcher. I'm a software developer, so I'm not an expert at this. I just find it kind of interesting. And I think that it's useful to know this stuff as a developer, particularly if you're a web developer. Hands up, who is a web developer versus just some other kind of software dev? Okay. Hands up, who isn't a developer, just out of interest? Okay, a couple, fine. Okay, yeah, so even though, that disclaimer aside, it's still really interesting to know this stuff. It's interesting to know what other people, nasty people, will be doing, and trying to break into your software. Okay. Before we start poking around, I just want to give some backgrounds on the most common way that computers communicate over the internet. And that's using a protocol called TCP/IP, which stands for Transmission Control Protocol over Internet Protocol. That sounds really complicated, but it's basically just two things together, and they're like agreements for how computers can communicate by transmitting data. And whenever you use the internet, you are essentially using this protocol without really knowing about it. And crucially, it was designed for robust communication over an unreliable network, which is what the internet is. It's not very reliable. And it is designed to allow two computers on a network and two applications, one on each of those two computers, to communicate. So for example, maybe at one end, you've got your web browser, you've got Firefox running on your laptop, and that needs to send some data out onto the internet. And so it passes the information that it wants to send and receive to the operating system that's running on your computer. So that's like Mac OS or Linux or Windows. And then what your operating system does is it breaks it down into little tiny packets. And it adds some information to that packet. So think of this as like if you had a letter, and then you were putting that letter in an envelope and writing the address on the envelope. That's what your operating system is kind of doing. And the header information includes like where it's coming from and where it's going to. And it includes addresses, specifically IP addresses, which I'll cover a little bit. And also, crucially, it includes the port. And so ports, when you have an application that wants to talk to some other application somewhere on the internet, it asks your operating system for permission to open a port. And these are numbered, and they're numbered from 1 all the way up to 65,535. There's a lot of them. And that port is how those packets, when they reach their destination, the operating system at the other end knows which application to pass it to. So yeah, so data from your web browser, operating system on your computer turns it into little packets, addresses where it's going to, it goes off on the internet, gets to the other end, the operating system at the other end reassembles it all, looks at where it says it needs to go, and then passes it off to that process. So the other aspect of the protocol that I just need to cover is the handshake that happens when your laptop first wants to start communicating with, say, google.com. And so before any of that data starts flowing, it sends special kinds of packets. The first packet is, you could think of it as like a message saying knock knock, and then the server at the other end says who's there, your laptop says me, and then the data can happen. That's when then the HTML for google.com comes to your laptop, essentially. They're not really called knock knock, who's there, and it me. These packets have special names. It's a SYN packet for synchronize, a SYN ACK packet, which means I've acknowledged your synchronize, and then an ACK packet. Don't worry too much about these, but it's just, that's the technical names. But that's only if there is an application at the other end that has asked for permission to listen to that port 443 in this example. But what about if there's no service at the other end? Well, in that case, the handshake happens again. But in this case, the operating system at the other end sends a different kind of packet. It sends an RST packet, a reset packet, to say, go away, there's nothing here for you. There's nothing to answer your request. Don't send me any data. So with this knowledge, we're looking for services. I said at the start, like, we're looking for services that are running on the internet, on a computer. And we want to know which ports are open and which ports are not. Is there something there or isn't there? How could we do it? Where are we? We could just ask, right? So we could just work our way through from port 1 all the way up to 65,535, seeing if anything replies or not. And if something replies with that SYN ACK packet that, yes, I'm here, then we could write that down. And then we could essentially build up a list of the ports that are open on that computer at the other end. This is not anything particularly special. It's got a name. It's called port scanning. And this is the first step, right? This is the first step in what we're going to do to look at a remote computer, see what services are running on it, so that we can then see, are any of those services vulnerable to common attacks that we can then perform? Does that make sense so far? Mostly nodding heads. Cool. OK. So let's do that. Let me find my terminal. There it is. OK. Let me bring up the other notes. OK, so we could just do that port scanning ourselves. Like, we could just work our way through from port 1 all the way up. But because this is a common thing that people want to do, there's a tool called Nmap, which stands for Network Map. And it's a port scanner. And it does a whole bunch of things. We're really only using like one tiny little aspect of what it does. And in fact, you can see that from if I'm in a terminal, I've typed Nmap on my terminal, and the output is like, there's a lot of stuff that it can do. But for now, all I want to do is I actually just want to pass it. That Google Hangouts is sharing your screen is going to get in the way. Hang on. Let me move this up a little bit. Is that better? Is that more easily visible? There you go. OK, so I'm going to run the command nmap on my terminal. And I'm going to pass in an address of a computer that I want to scan to see if there are services running. For the record, this is my own machine that I'm scanning. I have permission because it's mine. So I'm going to type in an IP address and my password. OK. And what this program, Nmap, is going to do is it's going to do kind of what I described. It's going to scan through all the ports and see which ones are open, and then write them down and show us. So we can see here the server at the other end is up, which is good. Otherwise, this would be a short demo. And it's saying that 997 ports are closed. Now, I said that there are 65,000 of them. Nmap, by default, only looks at the most common ones. Like, most of those ports are not used by anything at any time. So we don't, and it would take a long time to search all of them. So it just searches the most common 1,000, which is fine for what we need. And it's returning back that there are 3 ports running on this server at the other end. One of them is port 22, which it says is SSH. If you're not familiar with what SSH is, it's basically a service for remotely logging into another computer. So what this tells me already about this machine is that it's designed to be logged into remotely, which is interesting. That means if I knew a username and password, then this would be really easy. I could just log in and gain access. And then there's a couple more here, port 3000 and port 9200. Don't really know necessarily what they are. It's telling me that one of them is for the point-to-point protocol, and one of them is to do with WAP. These names actually come out of your machine on like a text file on your own machine. It's not necessarily the case of what's actually at the other end. So this is fine, but we do want to know more about these services. We said about we're looking for out-of-date services that have reported vulnerabilities that we want to exploit. So we can actually ask Nmap to do a little bit more. In fact, if I scroll up to the help, there's an option here, this one, -A, which enables operating system detection, version detection. That's the key thing. Script scanning and traceroute. So if I run the same command again, but with that -A, this takes a little bit longer because it has to actually connect to those ports and see what comes back. In theory, go on, you can do it. Believe in you. Yes. Okay. So this comes back with a whole bunch of more information, but you can still kind of see the same thing, right? It's saying the host is up. It's saying a bunch of ports are closed, and port 22 is open. And now it's actually connected to it. So it's telling me what version of software is running at the other end. Okay, and it's telling me that OpenSSH is running at the other end. Fine, whatever. It's also telling me that it's Ubuntu Linux. Useful to know. So this server is just some random server on the internet, but I already know what operating system is running, potentially, if it was a random server on the internet. And then the next one down, port 3000, is not PPP. It's actually a web server, and it's running Ruby on Rails. And it's running a really old version of Ruby on Rails. This is just over 2 years old. So that is promising if we were looking to break into this machine. And then finally, port 9200, it's telling me is Elasticsearch, which, if you're not familiar with the software Elasticsearch, it's like software for running your own little mini Google if you had a bunch of documents and data that you wanted to be able to query in the same way that you query Google. And so someone who has set up this machine that I'm scanning has installed, they're running a website, and they're running a search index. And it's open to the internet. And again, it's giving me a version number, which is really useful, 1.4.1. Okay. It also tells me a bunch of other things. It's guessing that it's Linux. We kind of got that because it said Ubuntu Linux above it. But it does a whole bunch of things to try and work out, like, what is this machine? And it does, bits of trickery here and there. Okay, so where's my slides? Okay. So that was the service discovery part of that list at the start. We found out what's running on this machine on the internet just by asking it, essentially. And so now we want to see if we can find any vulnerabilities in those services that are on that server. And specifically, let me bring up my notes. Specifically, I'm going to look at trying to find if there are known bugs in those pieces of code, particularly if they're old, and maybe there was a vulnerability that has been later patched. And also, I'm going to look a little bit at enumeration. So what I mean by that is, if you're trying to log into something, and you don't know the password, and you just try loads of passwords. Unfortunately for us, Metasploit, that program that I mentioned earlier, can do both of these things. So let's have a look at what it looks like to use Metasploit. So first of all, to Google. We saw that Ruby on Rails was running, and it was an old version of Ruby on Rails. So the simplest place I can start, were there any Ruby on Rails vulnerabilities? I'll make this bigger in a second. So if I search for Ruby vulnerability 2015, and because I only care about vulnerabilities that Metasploit, which is basically a big collection of vulnerabilities that you can run, I only care about ones that are in Metasploit. So I'm going to put Metasploit at the end of my search. There we go. Is that better? Yes. Sure enough, #1 result. Ruby on Rails. This module is a whitelist bypass vulnerability. So if we go and have a look at this, crucially, there are a whole bunch of different types of vulnerabilities. So there might be a vulnerability in some library that just leaks a little bit more information about the server. There might be a vulnerability that doesn't really do a lot. For the purposes of the demo, we're looking for the perfect vulnerability, which is the one that lets you execute code on the remote server. That's the one that you really want, because if you can do that, you can do anything, essentially. So in this case, there's a vulnerability in versions of Ruby on Rails from around 2015. Sounds promising. It'll achieve code execution. And actually, this vulnerability, I'm not making it up. This was a real vulnerability. It was basically, there was a developer tool that was included with Ruby on Rails back in 2015. And it was designed to only work if you accessed it from your developer machine while you were working on the code. But there was a bug in it, which meant that from the outside, you could basically bypass that and pretend that you were on the same machine, even though you weren't. So that's what the vulnerability is, by sort of sending it a particular message. There's definitely not enough time to go into how vulnerabilities work here. And crucially, if you're using Metasploit, you don't need to know, which is kind of the scary thing about Metasploit, is that you can do this without really knowing how it works. And that's kind of what I'm doing here. So I'm going to take the name of this module, and I'm going to go back to my terminal. Now, I don't want to go into too much detail about how Metasploit works and all the commands that you can run, because it'll just take too much time. But I'm going to run Metasploit and start it up. Metasploit is a bit like, they like to think that they're quite cool, so it comes up with like fancy ASCII art when you load it up and stuff like that. It's a little bit like you're in the Matrix. And you can see that it lists, like, it knows about 1,700 exploits, etc., etc. So I've got the name of the exploit I want to use. So I'm going to say use and then pass in the name of that. And then I'm going to find out what options there are for this exploit, like what I need to tell Metasploit about the place that I want to target. I'm going to say show options. And I get a bunch of options here, and there's really only one important one here, which is the target address. That's the target that we want to run this exploit on. And that's that IP address that I used earlier when I ran nmap. So I'm going to say set our host to that IP address. And that's enough. If I tell Metasploit to exploit that target, what it's going to do is it's going to connect. It's going to send that particular whatever it is. I don't know. Doesn't matter. And it's going to try and give me remote access to that server. So hopefully, if it works. Yeah, OK, great. Command shell opens. So I am now connected to that machine. From not having access, I've now got access. And that means that I can do things like look at the code that is inside this Ruby on Rails folder. Because I am a Ruby on Rails developer, I know that Ruby on Rails developers often have a .m file, which is where they put like configuration, like keys, maybe that like a key for an API or something like that. So I'm going to go and have a look at that. Looks like this code has some AWS keys in it. If you're not familiar with AWS, it stands for Amazon Web Services. That's a cloud platform for booting up servers and all kinds of stuff, sending emails and things like that. If I was a nasty person, then I could use those keys to perhaps try and see if I can create loads of really expensive servers and mine some Bitcoin until they notice that their credit card bill is £15,000. But I'm not going to do that, obviously. For a start, it says example, which is probably the giveaway that they're not real keys. So if you're taking a photo to, I saw you, they're not real keys. Okay, so that was really straightforward, right? Ridiculously easy. 2-year-old version of Ruby on Rails, done. And Rails is an example of a developer library, right? Like you've built a Ruby on Rails application, you've installed Ruby on Rails, you've left it for 2 years, and someone comes along and does this. But what about things that you install, right? Like Elasticsearch. That's something that's been installed on this server. It's not code that someone has written. So if we quit out of this and go back to Google, where are we? My predetermined Google search. So again, let's search for Elasticsearch. And it was version 141, vulnerability. And to keep things simple, I'm putting Rapid7 at the end, which is the name of the company that kind of look after Metasploits. They're sort of the maintainers. And sure enough, once again, right at the top, there is another vulnerability here. Again, remote command execution. That's the key. That's the cool one. That's the one we want. And it says it's exploitable by default on Elasticsearch prior to 143. And Nmap told us that it's running Elasticsearch 141. So once again, I'm going to take the module name. I'm going to jump to Metasploit. And I'm going to tell it to use it. Again, don't really need to know how it works. Doesn't really matter. Going to ask it what options there are for this exploit. Again, there's only one that I care about. It's the R host, the remote host. So I'm going to say set R host once again. And then again, I can just run exploit. Now this time, this is slightly different. It's worked, but instead of just giving me kind of a blank line at the end, it's actually loaded up a Meterpreter shell. So what Meterpreter is I mentioned that Metasploit is a framework. Okay, so it does a whole bunch of things. And one of the things it gives you is a thing called Meterpreter, which is a little bit nastier than what we had before. This is actually designed for this specific purpose. It's a program that is sort of can be embedded in a vulnerability. And it gives us a whole bunch of really easy to use commands like record microphone and screenshot. So if this wasn't a server, then there's some more nasty stuff I can do here. But it also gives me, the ability to look at the files on the machine. I can ask it who I'm running as. And yeah, I'm running as Elasticsearch because that was the service that I've kind of gained access via. So this is fine. Like getting access as these services is fine. But if you're familiar with Linux or Mac OS operating systems, they have multiple users. And so in this case, we're running as a user called Elasticsearch. And that's probably a limited user. Like they probably can't access all the files and do all the things. They can just do stuff to do with Elasticsearch. So what we really want is we want root access. We want admin access to the server so that we can basically access anything. Like it's then ours for once, basically. So what I can do now that I've got access to this machine, I can have a look at the password file. Now, this doesn't contain passwords, but it does contain a list of all the users on a Linux machine. Now, I don't care about all these first ones because they're all just the standard ones that are on any Linux server. But this one, from my knowledge of Ubuntu Linux and Linux in general, I know that the one here with ID 1000 is the first user that was created on this machine. And by default, I know that Ubuntu Linux, the first user that's created, tends to have the ability to elevate itself to be root by running sudo, which you saw me run earlier when I was using nmap. So I now have a username. Now I don't need to try a whole bunch of usernames to see what works. I know a username. So I wonder if the person that set this up perhaps used a common password. So I could remember that we saw that SSH is running on this machine as well. So that will allow me to remotely log in if I know the username and password for this server. So now I know the username. I could just connect and try loads of passwords over and over. But actually, as I said earlier, Metasploit can do that for us as well. So if I quit out of this Meterpreter shell, I can say, instead of using an exploit, I'm going to ask it to use, no, not an exploit. I'm going to ask it to use a scanner. I'm going to ask it to use an SSH scanner. Again, I'm going to say show options. This has a few more options than those two exploits that I used. Don't really care about most of them, but I do care about the rhosts again. I want to set the rhost up. Now, in this case, it's plural because actually this scanner will scan multiple machines. If I had, say, 5 machines that I wanted to try and log into, I could tell it that I had 5 to scan, and it would try them all. And also, I know the username already. So the username is XPT. And the final thing that I need to give it is a pass file, a file containing the passwords to try. Fortunately, Metasploit also comes with a whole bunch of password files. One of the ones it comes with that I'm going to use for the purposes of the demo is actually the top passwords from the big Adobe hack that happened a few years ago. So there was a big hack, a whole bunch of passwords were leaked, and this is a collection of the top 100 from that leak. I'm also going to set verbose to true just so that we can see it trying these connections one after the other. And then I'm going to say run, go for it. And what it's going to do is it's going to connect and it's going to keep trying common passwords. If any of these are your password for anything, then definitely change your password. It's also kind of worrying that the most common password on adobe.com was just 123456, followed shortly by 123456789, and Photoshop. I mean, it's pretty. Yeah, good. I mean, at least it's specific, I guess. You're going to remember it. So hopefully it's going to eventually find a password that this user used. Probably not Macromedia. Oh, there we go. It's found it. It's I love you. So this user set their password to I love you. Big mistake. So we can now quit out of Meterpreter. We could use Meterpreter to connect and run some commands, but just for the purposes of the demo. I'm going to quit out of Meterpreter. Can everyone still see that okay? Is it? Yeah, fine. And I'm going to use SSH to connect, just as if I was actually this person. Where is it? What is it? There we go. It's going to ask me for the password. I love you. And then we're into that machine. So this is the third time that we've got into that same machine. But crucially, let's see if this is still set up as the default. If I type sudo who am I, I'm basically saying try and become root and then say who I am, just kind of for proof. It's going to ask me for the password again. Yeah, I got root. So I now have access to this machine through 2 vulnerabilities. One of them that gave me access to look at the list of users on the machine. And then from there, I tried a bunch of passwords and got in. So that didn't take very long. Fortunately, where are my slides? They're on one of these. There we go. Fortunately, this particular avenue of attack is really quite easy to protect yourself against. If I can find the right notes. This one. Okay. So first of all, that first attack, we exploited a vulnerability in an out-of-date library. So as a developer, I've installed some library or some tool. It's running as part of my application. And it's really, really, really important to keep those dependencies up to date, especially for projects that you've done, you've finished, they're running out there in the world, and you've forgotten about them. A year or whatever can easily go by, and there's no reason for something old. It doesn't have to be old. You know, if the vulnerability happened yesterday, there's a Metasploit module written for it the next day, and the day after that, someone's scanning your server looking, trying to use it. So keep dependencies up to date. If you can, automate doing that. There are a whole bunch of tools out there now. If you're a developer and you use GitHub for your code, there are a bunch of tools that you can use, things like Dependabot and Greenkeeper, and I think it's called Snyk or Sync. Is it Sync? And what they basically do is they look at your code, they look at your dependencies, and if any of them are out of date, it sends you a pull request and says, hey, this library's out of date. Please update it. And you can look at the changelog and see if the tests pass, assuming you've got a good test suite. So keep dependencies up to date. If you can, do it automatically. And also follow the community for large dependencies. If you're writing Ruby and Ruby on Rails, then follow what's going on in the Rails scene. If it's Python and Django or whatever, Elixir. So that's out-of-date libraries. In the case of old software, like that version of Elasticsearch that we exploited, keep installed software up to date. This is only really relevant if you're managing servers, or maybe you're managing your own little infrastructure of Docker containers or something like that. If you're using something like Heroku, then they're kind of doing this for you a little bit. But still, if you're installing anything on any server out on the internet, then keep it up to date. Again, if you can, automate it. Operating systems do let you do that. Subscribe to product updates for that particular service that's listening on the internet. And also, it sounds kind of weird, but have a proper firewall set up if you've got a computer out on the internet that is, has some stuff open on it. You might be like, well, why? Because things need to connect to it. But it's really easy to install something, maybe have it misconfigured, forget about it, and it's listening to the world and you don't realize. I say this because it happened to me. I had a version of Redis that was running on a server, and I didn't realize that it was misconfigured to listen out on the internet rather than only on the machine. And so, yeah, that can definitely happen. And finally, for that last one, don't use common passwords. It sounds silly, but as a developer, you're often setting up things where, you think, oh, I'm not going to log into this all the time. I'm not going to set it up all the time and access it. So I'll just use something simple because it's only on the machine anyway. It's all fine. Don't do that. Don't use common passwords and don't reuse passwords. Maybe there's a vulnerability in one thing that you've set up that gives access to the password that someone can use for something else. Ultimately, use a password manager. I use 1Password. It's the logo. It's really cool. You should use it. The other thing actually on the old software does also cover old libraries of software and things like that as well. Who here has heard of Heartbleed, which was a vulnerability from a couple of years ago? Okay, quite a few. That was a vulnerability in OpenSSL, which is a library that a whole bunch of things use. And it seems obvious to keep installed software up to date on things you manage, but Heartbleed was disclosed in April of 2014, and a month later, there were still tens of thousands of the most popular websites on the internet still vulnerable to Heartbleed. So there were people out there with really popular websites that were not following these rules. So yeah. Where are we? I did say that I would mention briefly other attack vectors. You know, I've really only covered one specific thing: finding services, finding ones that are out of date, searching for exploits for them, and using them. There are others, things like social engineering. We've probably all heard of that. You know, I did some port scanning there, but if I can ring up someone and pretend to ask them information about their servers and they aren't tell me, then that would be good. Physical access as well. Like, this is remote access over the internet, but physical access to a machine is a completely different ballgame. Also, rootkits. So we got root at the end of that where we logged into SSH, and we had root access to the server. There are things called rootkits, which at that point I could then install. And what it would do is it would basically hide from the real administrator that I was ever on that server or ever using it. And I would basically just keep access to that machine forevermore. And it would be very, very difficult for them to know, especially if they're doing things like leaving software lying around that's out of date. Also, unpublished vulnerabilities. You're kind of on your own there. Like, if someone's keeping something to themselves, then you can't really protect yourself against it. Just good security practices in general. And also specific vulnerabilities to your software or your app. You know, this is all well and good, but if you write some code or some software that has a page or a bit of it that's only viewable to administrators, but you forget to check that a user is an administrator, then, and someone's poking around and tries to get access, then it doesn't really matter what vulnerabilities common vulnerabilities you're protecting against. They can just poke around and access stuff. So definitely following good security practices is always important. Yeah, I hope this has been interesting, and mostly for the people that don't keep their libraries up to date, I hope that it's terrified you into running bundle update or whatever it is that you need to do on your code. Yeah. Any questions? Yes, at the back. Yes. What? Yeah. What? Was the question about Wireshark? Oh, okay. Wireshark is not a port scanner. It's a tool for sniffing traffic. Yes. Yeah. So Wireshark is yeah. The question was is Wireshark part of this sort of, I guess, part of this stuff? Yes, it is. Wireshark is a tool for capturing traffic. So if you're sat in the middle, that diagram, TCP, where are we? Back a little bit. Yeah. When you've got your computer, it doesn't go straight out onto the internet, right? Like, first it goes, in my case, like to some Wi-Fi router in here somewhere, and then out onto the internet eventually. You can, with something like Wireshark, that's a tool for sitting in the middle, and essentially it's like a phone tap, where you can see all the traffic coming in both directions. That's not necessarily suitable for exploiting vulnerable servers, but it's useful for seeing what traffic people are sending. Nowadays, for malicious purposes, it's kind of less useful because most computers now encrypt their traffic all the time. There was a time when you would access websites and it would be unencrypted most of the time, in which case Wireshark would see it and it would be there clear as day, the stuff that you were doing on the internet. Someone would be able to sniff it. But yeah, that's definitely another tool in the arsenal for people doing this kind of thing. Anyway, yes. Definitely. Yeah, well, on Apple, right? Like, that was only the other day that there was the, vulnerability where basically if you just hit enter twice on the login when you got asked for the admin password, it would just let you in anyway. Yeah, I mean, definitely proprietary software has its risks, perhaps more so than open source software, where things like Elasticsearch, where that vulnerability was, found by someone, disclosed, and and patched and so on and so forth. Maybe in some ways proprietary software, I don't know, like it's perhaps slightly more difficult to exploit a vulnerability if it gets quietly patched and it's not necessarily publicly disclosed. With open source software, it's really obvious if a security vulnerability gets patched, because you can see like this was the code before, and then this was when the security patch came out. You can kind of tell what they're protecting against. But yeah, like proprietary software is definitely a problem as well. And again, stuff that you wouldn't necessarily know about. Yeah. That's a great question. If you look after a server on the internet, there is software that exists. One of them is, for a start, in the case of, in fact, in the case of everything we did, there's some software called intrusion detection systems, which you can install on servers. And that basically watches all of, a little bit like Wireshark, watches all of the incoming traffic that comes in on your machine, and will look for patterns of data and information. Any decent intrusion detection system would have picked up everything that we did today, from the port scan that I did to Metasploit to all of those SSH connections I did. And in the case of SSH specifically, trying all of those passwords over and over is really, really obvious, right? Like a server can, like you can spot that a mile off. In fact, there's a piece of software called Fail to Ban, which is specifically for protecting against SSH attacks like that. And basically, if you try a password, I don't know, 3 or 4 times, it just blocks that person from accessing anymore. You can also disable passwords for SSH and only allow keys instead of passwords. That protects against enumeration. It doesn't protect against me gaining access to some server where someone has left that key maybe, and then I can go and get access. I think that happened once actually with my AWS example, where like someone got some AWS keys, they used that to access AWS where there were some backups, and in those backups was an SSH key that then gave them access to log into some server somewhere. So sometimes it's like stepping stones. But yeah, there's definitely software you can install. Not specifically. No, I don't really have any specific suggestions. I really like we use, I mentioned earlier, Dependabot. So that's a tool for if you're looking after code. It can look at your vulnerability, your libraries, and seeing what's out of date. I don't know if anyone else has suggestions of sort of security websites that publish, common vulnerabilities and when they're released or anything. Might be able to help. Pass. Yeah, at the back. Yes. That's a good question. You can, so multi-factor authentication does tend to be for like customer-facing things. Like if you're building something and you set up 2FA on your thing that you're building for people, that's, I mentioned at the end there about domain-specific vulnerabilities, about gaining access to your app in some way, and enumeration and stuff like that. That definitely protects against enumeration. You can find a common password, but if you don't have the person's phone where the token has come through, then that is, that's going to help. In terms of SSH specifically, so the attack I did where I logged in over SSH does support 2-factor auth. It's kind of weird and clunky, and most places don't bother. I think I only have one really paranoid friend that set up 2-factor auth on their SSH login. So it would definitely protect against it for sure. You wouldn't be able to do the whole password scanning thing. Yeah. It is, but only in terms of logging in as a user. It doesn't protect against the 2 vulnerabilities we did at the start where we were exploiting bugs in code. No 2-factor auth is going to protect us there from a vulnerability. Any other questions? Yes. Yes. So actually, that's a good point. Yes. You may have spotted, if you were eagle-eyed, when I was doing my Google searches, if I can find my search engine again, there it is. You'll see, if I go back a step, this code here, CVE 2015-1427. So CVE stands for Common Vulnerabilities and Exposures, I think. These are basically codes that are given to every published vulnerability that ever happens. Every disclosed vulnerability has a CVE code. And so, yeah, you're right. If I think there's a CVE listing website out there. Yeah, there we go. The only thing about that is that that's going to be like, there's a lot of vulnerabilities, and some of them are less important than others. For the purposes of the demo, I've picked out some really killer vulnerabilities that gave us, access to the machine. A lot of vulnerabilities will be in this specific situation with this specific setup, then this can happen, and so that's not necessarily going to be super useful if you're a developer working on multiple projects and you've got things all over the place, and you don't necessarily need to know about a vulnerability in an old version of Flash that was found the other day, for example. But yeah, definitely. Yes, of course. Yeah. Any other questions from anyone? Oh, nearly off the hook. Yes. Yeah, of course. Thank you. Greenkeeper. Greenkeeper, yeah. If you go on the GitHub Marketplace, which is kind of a new feature on GitHub, they have a big list of, well, I say big, it's about 5 or 6 it's not a big list, it's a small list. They've only just started with the marketplace. If you go on the GitHub Marketplace for stuff to do with dependency management, and if you just Google, then there's a whole, was I right? Oh no, 5. Okay, that's not great. But Dependabot is one of them, and Snick, not Sync. There we go. Snick. Dependabot, Snick, and Greenkeeper are the ones I mentioned. There's a couple of others here, but there are others out there as well. There's a whole bunch of them. Oh goodness. Is more questions okay? Yeah. Okay. Yeah, go for it. Yes. Yep. Yes. I mean, it depends on your threat model. It depends on what you're worrying about. If using 1Password and using it in the cloud means that you always have a decent password and you never reuse passwords and you don't share them in an insecure manner, then the risk of it being in the cloud is probably okay compared to those other things of like writing them down on a Post-it note because you've not set it up to run in the cloud and share with friends and stuff like that. Friends, team, obviously not friends. If you're more paranoid, you can use 1Password only locally, as you describe, or something like KeePass or KeePass X, which you could perhaps put on Dropbox, and then that means that it's encrypted, but not in the not out in the cloud. In fact, 1Password supports that as well. You can actually use 1Password with Dropbox, and it stores the files on Dropbox, and so you can access them in multiple places, but they're not, Dropbox can't read them. So yeah, I'm a little bit paranoid about cloud-based password management. It seems a bit weird, but yeah, it depends on if that helps with your password policy, essentially. Well, yeah, that too. Yes, I will share them afterwards on the meetup page, and they'll be on the recording of it as well. Okay. Thank you.